Introduction to Third Dimension, 3D. A new workspace called 3D Modeling comes with AutoCAD 2009. This workspace displays the dashboard palette, tool palettes window, and the workspaces, standard, and layers toolbars. The layout tabs at the bottom of the drawing window are hidden. AutoCAD comes with a number of toolbars and palettes that contain 3D related tools for creating, editing, and navigating your drawings. Everything you have done up to this point has been with X and Y coordinate values. This is all about to change as you step into a whole new direction with the Z coordinate. The inputs of relative and absolute coordinates for 2D drafting formats are great for both 2D and 3D drafting. The only difference that you will find when doing 3D drafting is the need to enter a Z coordinate value. Along with those coordinate input formats, the relative polar coordinate input is expanded to include two additional formats called cylindrical and spherical, designed for 3D drafting. Absolute X, Y, and Z coordinate. Working with absolute coordinates in the 3D drafting is just like you would input them for the 2D drafting, except you add in the Z coordinate. You supply the coordinate input in the format X, Y, Z. An example of using the line command to draw a line in 3D space using absolute coordinate entry is this. Specify L on the command line and press Enter. Specify first point, 10, 10, 0, and press Enter. Specify next point, 14, 10, 0, and press Enter. Specify next point, 14, 16, 0, and press Enter. Specify next point, 10, 16, 0, and press Enter. Specify next point, 10, 10, 0, and press Enter. Specify next point, 10, 10, 8, and press Enter. Specify next point, 14, 10, 8, and press Enter. Specify next point, 14, 16, 8, and press Enter. Specify next point, 10, 16, 8, and press Enter. Specify next point, 10, 10, 8, and press Enter. Now again, go to the line command and complete the sketch. The next coordinate is a cylindrical coordinate. It is used to draw a sketch by specifying angles in X and Y plane. Cylindrical coordinates. Cylindrical coordinates is the first of two coordinate entry formats based on relative polar coordinate entry for 3D drafting. Specify the coordinate input in the format of at XY distance less than angle, Z. An example of using the line command to draw a line in 3D space using cylindrical coordinate entry is as follows. Command line. Specify first point, 10, 10, 0. Specify next point, at 4 less than 0, 0. Specify next point, at 6 less than 9, 0, 0. Specify next point, at 4 less than 180, 0. Specify next point, at 6 less than 270, 0. Specify next point, at 0, 90, 8. Specify next point, at 4 less than 0, 0. Specify next point, at 6 less than 90, 0. Specify next point, at 4 less than 180, 0. And specify next point, at 6 less than 270, 0. Now press Enter and come out from the command. Again, go to Line command and pick a point. To draw a line in downwards, type as specify next point, at 0 less than 90-8. And continue to finish it, or simply select points to finish the sketch. Spherical coordinates. Spherical coordinates is the second of the two coordinate entry formats that is based on relative polar coordinate entry for 3D drafting. You supply the coordinate input in the format of at xy distance less than angle from xy. Command line. Specify first point 10, 10, 0. Specify next point at 4 less than 0 less than 0. Specify next point at 6 less than 90 less than 0. Specify next point at 4 less than 180 less than 0. Specify next point at 6 less than 270 less than 0. Specify next point at 8 less than 0 less than 90. Specify next point at 4 less than 0 less than 0. Specify next point at 6 less than 90 less than 0. Specify next point at 4 less than 180 less than 0. And specify next point at 6 less than 270 less than 0. Now come out from the command by pressing Enter. Again, go to the command and select a top point. And type specify next point at 8 less than 0 less than 270 and press Enter. Or simply select 2 points to finish the sketch.
Thickness. Thickness is a property of most 2D objects, such as lines and circles. When you change the thickness of a 2D object, you are creating a surface out of the object, or a set of surfaces. These surfaces hide objects behind them, unlike wireframe models. If you add a thickness to a circle, a cylinder is created. Type thickness on the command line and press Enter. Now specify a thickness. For example, type 2 and press Enter. The new objects will be given the new thickness value. For example, draw a line using the line command. The line is added with thickness. To get a line without thickness, give the thickness value as 0. In rectangle command, thickness is also available. Let's see how to use the thickness option in the rectangle command. Type REC on the command line and press Enter. Now specify a thickness of a rectangle. For example, type 2 and press Enter. Specify a first and second corner point of the rectangle. Thus, the thickness is added to the rectangle.
Extrude. Extrude allows you to take an open or closed 2D object and create a solid or surface out of it. When you extrude a closed 2D object, such as a closed polyline, ellipse, circle, or region, you create a solid. If you extrude an open 2D object, such as an open polyline, spline, line, arc, or elliptical arc, you can create a surface. After selecting the objects or faces, if you want to extrude, specify a distance and direction to create the extrusion in. During the extrusion, you can select a path to extrude along which can be a 2D object or an edge of a solid or surface. The shortcut key used to type on the command line is EXT. Here are the steps to be followed. Draw a rectangle on the drawing area. Go to Home tab and select the Extrude command. Now, the command line asks you to select an object to extrude. Select a closed object, which should be a closed polyline. After selecting the object, press Enter. Now, the command line asks you to specify a height of extrusion. Specify the height. For example, type 10 and press Enter. Thus, the solid object is extruded. Let's see some sub-options in Extrude command. Direction. It specifies the length and direction of the extrusion with 2 points that you specify. Path. It selects the extrusion path based on a specified object. The path is moved to the centroid of the profile. Then, the profile of the selected object is extruded along the chosen path to create solids or surfaces. Taper. Tapering the extrusion is useful specifically for parts that need their sides defined along an angle used to create metal products boundary. Avoid using large tapered angles. If the angle is too large, the profile can taper to a point before it reaches the specified height. Positive angles taper in from the base object. Negative angles taper out. The default angle, 0, extrudes a 2D object perpendicular to its 2D plane. All selected objects and loops are tapered to the same value. Specifying a large taper angle or a long extrusion height can cause the object or portions of the object to taper to a point before reaching the extrusion height. Revolve. Revolve allows you to create a solid or a surface based on selected objects and a specified axis that they should revolve around. If you use open objects to revolve, the result is a surface revolve. If you use closed objects to revolve, the result is a solid revolve. The shortcut key used to type on the command line is Rev. There are many sub-options available in Revolve command to revolve an object easily. They are Object. Instead of selecting the 2 points for an axis, simply type O on the command line and press Enter to select an object for axis. X. It automatically takes X-axis as an axis for the revolving object. The radius of an object is the distance between the X-axis and sketch. Y. It automatically takes Y-axis as an axis for the revolving object. The radius of an object is the distance between the Y-axis and sketch. Z. It automatically takes Z-axis as an axis for the revolving object. The radius of an object is the distance between the Z-axis and sketch. Start angle. It is used to start a revolve of an object with variable angles from the X and Y plane. Here are the steps to be followed. Draw a sketch on the drawing area. Draw a line which is indicating the radius distance from the sketch and is going to be a center line for a revolving object. Make sure the workspace setting is set to be 3D modeling using workspace setting in the status toolbar. Go to Home tab and select Revolve option. Now the command line asks you to select an object for revolve. Select a sketch and press Enter. Now the command line asks you to specify a start point. Select a point on the line to indicate the axis start point. Then the command line asks to specify an endpoint. Select an endpoint of an axis by selecting the endpoint of a line. The selection of 2 points indicates the axis of a revolve object. Now specify an angle of revolution as 180 and press Enter. The object gets revolved. Let's discuss a sub-option called Start Angle. Draw a rectangle on the drawing area. Draw a line which is indicating the radius distance from the sketch and going to be the center line for a revolving object. Go to Home tab and select Revolve option. Now, the command line asks you to select an object for revolve. Select a rectangle and press Enter. Now type O on the command line and press Enter. The command line asks you to select an object for axis. Now, select a line and press Enter. Type ST on the command line and press Enter. The command line asks you to specify a starting angle. For example, type 45 and press Enter. Specify a total angle to revolve. For example, type 180 and press Enter. The object gets revolved. Note, the other sub-options in this revolve feature are similar to the previous versions of AutoCAD.